Hi there, crew, and welcome to another update on our situation in Iceland. I'm Geology Professor Shawn Willsey. Thanks for joining me. Today's December 31st. It's New Year's Eve. It's about 11 a.m. here Mountain Standard Time, about 6 p.m. over there in Iceland. Some of you maybe have already rung in the new year, so Happy New Year, and others of you might be just getting ready to celebrate. So I hope 2023 was good for you and 2024 is even better. I do want to let you know that I was gone the last week or so. So if you're wondering what happened, we were on a Christmas trip with our family for the last week. So apologize, didn't do any updates during that time, but I did put together some videos while we were in southern Utah. And so you can look forward to a couple more new field videos from that area around St. George. Let's go ahead and just jump right to it. What I'd like to do today is give you a little bit of an update on the things that have been happening over the last week, and then look forward to the future a little bit, and then maybe kind of sign off for the year with a little recap in terms of my YouTube channel and what we've done together as a team collectively. And looking back, sometimes looking back gives us that nice perspective of having accomplished quite a bit. So the big takeaway, I suppose, is that since my last update about a week ago, we have not had an eruption, but we've had continuing uplift of especially the GPS station near the power plant, but regionally we've seen this as well. All the GPS monitoring stations are showing uplift, and of course we've interpreted that to represent inflation of the magma body beneath in the subsurface, right? So we're looking at that slow but steady movement of the surface upward, and we are interpreting that as magma being injected into the subsurface, causing that uplift. So let's go ahead and jump into some data here and some things I want to share with you today. Let's start, of course, as we often do, with the earthquakes. Seismicity's been pretty slow over the last week. It's what we've seen, I suppose, after that eruptive event on December 18th. So here's our last 24 hours, about a week or so of earthquakes. You can see not many, maybe a couple dozen or so earthquakes there, and mostly in the low magnitude range. If we screen out magnitude 2 and above, there's none. Magnitude 1, looks like there's like 6 or so. And so again, seismicity's been constant, but much reduced over what we've seen previously. We've been monitoring this thing now for a solid 2+ months since the end of October. And so we've kind of seen a lot of different patterns come and go during that period of time. But seismicity is down, and even though the seismicity is lower than what we've seen previously, that's somewhat to be expected at this point with what's taken place and what's transpired. This magma body in the subsurface has already created space for itself. It's already erupted at the surface. And so the next eruptive event might be one in which we see very little precursor earthquake activity. So there might be not a whole lot of seismic noise that precedes this earthquake activity. Remember, on December 18th, we did get a little flurry of earthquakes as that magma body broke through the last, half kilometer or so of the crust in order to produce that eruption. And we might not get that now because we've established this plumbing system. The magma has a path to the surface, and it doesn't need to break a lot of rock to do so. The only thing that might cause more seismicity is if we get an earthquake in a new, or excuse me, if we get an eruption in a new area or a new region, that would need to correspond to increased earthquake activity, higher frequency and larger magnitude quakes. Or if we have a really long period of time of magma inflation and this system becomes highly overpressurized such that it produces a larger volume eruption than what we saw on December 18th, then we might see some increased earthquake activity associated with that. So those are some things to kind of look for. But the earthquakes were most helpful preceding the last two events, November 10th and December 18th. Now that we've got a vent and a conduit to the surface, the earthquakes might not be the big precursor indicators that we have seen them be in other eruptive events. So, but we'll keep an eye on that. We'll see. They're still worth monitoring. They're still worth looking at that data to see what happens moving forward. Looking at we've mainly been focusing on this GPS station here. Let me make this a little bit bigger for you. The one near the Svartsengi power plant. And again, just to review, if you haven't been following us in the past, we've got three graphs here. One that shows the north-south movement of this specific GPS station. So either it's being deflected to the north or south. And then the middle one with the green is the movement east to west. And then the final one in the red is the movement up and down. So each GPS station records three-dimensional motion, north, south, east, west, and up and down. And each one of them is somewhat telling. I think for simplicity's sake, and the thing we've been focusing on mainly is this bottom one here, which is uplift. So you can see going into late October, slow and steady uplift, culminating with the big movement of the magma off to the east, forming a dike that ran sort of northeast, southwest. That's this big sort of kick down. So that magma drained out of the area beneath the power plant, moved over into what they're calling the magma tunnel or the dike off to the east. And then it began to inflate again. So going into and throughout the month of November, there was fairly steady inflation, but not linear. This is not a linear growth pattern here. A little gap, few gaps in the data when the weather was really bad, and the GPS station was just getting rocked by the winds and such. And then you can see another kick down here that was our December 18th event. So that was our eruptive event in mid-December. And since that time, so for the past 2 weeks or so, we've been seeing the uplift resume. And again, we're correlating that or interpreting that as reinflation of the magma chamber. And now where we are today at the end of the year, December 31st, is pretty much, if you look at these dots here and where they're at on the y-axis, they pretty much correspond to where we were prior to the eruption on December 18th. So a lot of people feel like, hey, it's go time. It could happen in the next day or two, and I agree to some degree that we are at a point where the uplift is matching what it did prior to December 18th. But I do have a caveat kind of to put there. One is the subsurface conditions before December 18th. What those were at that time, that's not exactly where we're at now. Remember that this was an eruption on December 18th, and so we did actually get magma moving towards the surface, breaking that last bit of rock. And now here we are at the end of the year, December 31st. We've increased the space that the magma can occupy in the subsurface. So that event on December 18th made more space in the subsurface as it broke through the last remaining bit of rock. Remember also that this eruptive event on December 18th occurred along, at its peak, a 4-kilometer long fissure. So even though this uplift data is just up and down, remember we created space not just in one location where the vents were, but those vents were actually spread out over a 4-kilometer length. So I guess what I'm saying here is, although an eruption in the next day or two is very possible, I wouldn't be surprised if the uplift of this station continues and exceeds where we were pre-December 18th, because we have more space. There's more space in the subsurface for the magma to intrude into. And so are we at that trigger point, that threshold? Maybe not. Maybe we're not quite there yet. And so maybe this thing could take a few more days, possibly weeks, to get to the point of an eruption. And let's also remember that another possible scenario here is no eruption. It's very common in Iceland and in other volcanic systems to have periods of magma inflation and influx that don't result in eruptions. You sometimes actually have deflation, so we might even see areas drop a little bit as other areas possibly rise. And none of those need to necessarily culminate in an eruption. Certainly, we're entering a phase in this region in Iceland where eruptions are very likely in the near future over the next few weeks, months, years, maybe decades. But that doesn't mean that every single magma inflation event is going to result in an eruption. Okay, we didn't see this one on November 10th result in an eruption. It produced a lot of earthquakes. It evacuated Grindavík, but it did not produce an eruption. The event on December 18th did result in an eruption. So again, there's nothing sacred about reaching this point. There's nothing guaranteed in terms of an eruption taking place, if that makes sense. The other thing I wanted to show you with respect to that is if we go to the, um, let's add the, oh good, I got the GPS stations on here. Or maybe I just took them off. There we go. So if we look at some of the other stations, we've been focusing on this main station here, which I believe is the one closest to the power plant. I think it's this one right in here. Um, oh, maybe I lost them now. Where are all those? There they are. Oh, it's right here. Yeah, there's the station right here that we've been focusing on. But if we look at some of these other ones out here, like here's the one. Um, which one do I want to pick here? I could pick any of them. I want to pick the one out here by the Eldvorp craters, although I think we'll see this at some of the other ones as well. If we look at this specific station and look at its uplift data, let me make that a little bit bigger for you. Maybe that's about, that might be as big as it goes, but that's hopefully okay. If you just look at this graph here, so here we were in October at this other station. There it is ramping up. The November 10th event where the magma drains off to the west. Reinflation in this area, and then the December 18th eruption. Notice where we're at now. So there's our last data point, and this last data point's maybe December 30th, so it's a day or so behind. But notice that that elevation is not even back to the pre-December 18th elevation at this station. So while we're seeing the area under the power plant reach the same elevation that it did prior to December 18th, other stations in the area haven't reached that threshold yet, which suggests potentially to me, and maybe you, that there's still more space, right? That maybe a way to think about this thing might be to think of it like it's not quite like a balloon. Maybe it's a balloon with a bulge. Like maybe there's one little spot on the balloon that's bulging a little bit more, and that's the area under the power plant, but we would still need the entire balloon to continue to inflate and rise before we get to the point of an eruption. So notice that we're still a good, what's our scale here? Maybe 30 millimeters at this particular station. We need 30 more millimeters of uplift to reach that level there. If we look at another one here, and I just looked at a few of these earlier, so hopefully here's another one. We might see the same sort of thing. Yeah, same sort of thing here. Let me make that bigger for you. Hopefully, well, it's more blowing up more the things to the right than the things to the left. But you can see the same pattern here. There's the uplift November 10th and continuing to rise going into the eruptive event on December 18th, drops back down. And then here we are today around December 30th, 31st, and we're still a good, 10, 20, yeah, about 30 millimeters, 3 centimeters below where that threshold was. And we're quite a ways below the inflation we saw before November 10th. And so something that's maybe just worth mentioning. And so I just want to point that out to folks is that while this graph shows us getting back to that threshold, we're not quite there on some of these other GPS stations. And I think that's worth mentioning, that one specific GPS station is not the end all be all. We need to look at the whole data package and see what it's showing us. So hopefully that's helpful there. I'd be interested to hear your perspectives on that as well, as always. The Met Office, their latest update's a few days old, December 29th. And just kind of going through this briefly, land continues to rise. They also point out that the GPS station has now reached a similar height to what it was just before December 18th. And we talked about that. And let's see, what else do we got here? It's difficult to say that the land rising slows down in the run-up to the next eruption, but this has been the case in other eruptions. Okay, so the uplift is not really slowed down a whole lot, but they've seen that in some instances, but that's not necessarily a predictor. And it's uncertainty about how much magma pressure has to build up in before magma starts to reach the surface. Let's see what else. It's not accompanied by as much seismic activity. The reason for this is that the events of November 10th and December 18th, great tension was released in the region when magma made its way through the Earth's crust. That's kind of what I talked about. In the run-up to the last eruption, there was quite a few earthquakes over 3 and one over magnitude 4. With the continued earthquake, seismic activities continue likely to increase again. Yeah, so it's saying the same thing that I mentioned, that we had we broke that fresh rock. Earthquakes occur when brittle rock breaks and fails and fractures and shifts. Now that we've already created conduits to the surface and broken up a lot of rock, we may not see that same kind of earthquake signal. There's still a chance of an eruption. The odds are increasing with each passing day. It's most likely to erupt again near the Sinuk's Giga crater between Stora Stogafell and Hagafell. It's important to remember that magma flow does not always end in an eruption. Again, that's what I mentioned, that we might just get intrusion of magma and then we don't get an eruption that goes along with that intrusion. Yeah, and it's important to emphasize that the last eruption started with very short notice. And I think that's very much worth mentioning, is that the most likely outcome, if we have an eruption, is very little warning. That basically this thing ramps up, maybe a few earthquakes, GPS continuing to rise, and then we get a full-blown eruption. So that's some of our data. Let's turn to some of the news coming out of Iceland. And so thanks again to Amanda Joe for sending these on to me. So now that they've built up the berm or the wall around the power plant in the Blue Lagoon, their attention now has turned to the town of Grindavik. And so they have a design. They've had the design for a while, but I believe the work has started. Or maybe it might have started yesterday. They might take today and the New Year holiday off, but then they'll be right at it. And phase one for this structural mitigation project is kind of this wall you see here. It doesn't totally encompass the town, but this is the area where lava moving from the north would most likely impact the greatest part of town. And so they've kind of prioritized this bit of wall here. And they've started, I think they're going to raise it up a few, maybe 2 or 3 meters, get it built, and then they'll come back and then raise it up another couple of meters as well. And then I think they'll eventually probably extend it a little bit to the east and the west to maybe protect some of these other structures or buildings or homes that are on the tangents of that. I actually drew that on Google Earth here, and I want to thank a viewer who wanted to remain anonymous, but he sent me a nice little KMZ file of the most recent lava field. So this is our December 13th lava field shown here in red. There's the power plant in the Blue Lagoon. And then I've actually drawn on here, using that last image I just showed you, the extent of the berm. Let's see, where is it at? There it is, right here. That would go around Grindavík. And so maybe we could turn it this way if I'm not making you too seasick, and kind of put together that same sort of view. So the idea here is, if we have an eruption at the south end of this last eruptive phase, or even further south, maybe towards Hagafell or something like that, those lava flows would come down between these two topographic high points, and then run into the wall. And then again, what we're trying to do is not stop the lava, because that's pretty much impossible, but divert it, right? We're trying to get that lava to go somewhere else, maybe slow it down. If it slows down, it's going to crystallize, and get it to move somewhere else. It is, it's not a perfect solution. Could the lava, if you have a large volume eruption, could the lava override your structural barrier? That's possible, but doing something is oftentimes better and more productive than doing nothing. And they've also recognized, in terms of insurance and just outright how much financially is here in this town, the cost of building the berm is still a good idea, right? This is a cost benefit analysis, and the benefit of saving the town, the fishing harbor, and all the economic ramifications associated with it are greater than the cost of building this thing. So, and you can look at, I'll put those links to those articles in there, but this gives you a little bit of an idea of how that might play out. And so we might get an eruption in here. We're still thinking that the most likely place for the eruption is close to where we saw these last vents. That's still, that magma is not completely solidified and cooled, and so it still, I think, represents a weak point. So the most likely place for an outbreak or an eruption would be between Hagafell and Stora Stogafell, these two hills here. Let me turn it back so north is the right way, so that's what you're used to. And so we'll have to see. So they're working on that defense structure there, which is really great, and will probably take a few weeks, I would imagine. But the power plant one came together pretty quickly, and so I imagine that'll be the case as well. Um, it is worth mentioning that Grindavík residents have been allowed back into their homes even for overnight stay, but it's not recommended. So this is an article about the police chief saying, hey, even though you can stay, it's not recommended, but you're not being prevented, that there's still a risk there. And Amanda Joe got some crude numbers for me, and there was about 50 to 60 families that returned home to Grindavik over the holidays. And then she thinks, now that the holidays are over, it's probably more like 30 or so. And those are just her estimates based on conversations, I suppose, with other folks. Um, so there we have it. So where are we at now? What's the conclusion of this story? Well, we're still in a wait and see mode, and I think if anything, this geologic episode that's taken place over the last 2 months is taught us all geologic patience, I suppose, that the time scale of geologic events, even though we see these things flash up on our news feeds, volcano in the Philippines erupted, or there's a earthquake in China, or whatever it may be, it seems like these big things happen like fireworks in our brains. But what we're seeing here is something that's really more typical, that it's playing out. We don't know where it's going to go. We know what's happened. But it's a fascinating learning opportunity, right? It's a great time and situation to learn more about the volcanoes in this area, how the tectonics and the earthquakes all mesh together. So it's an incredibly valuable learning opportunity. We're also learning, how do communities deal with these hazards? What's the best way to manage risk? How does public safety and the role of public officials, how does that play into it? And so we're really getting a nice lesson as this event plays out slowly. And of course, we hope for the best outcome. We hope that if there is an eruption, that it heads out maybe into this area out to the east, and it doesn't head towards the town. But we're planning for the worst, and I think that's the best way you can go about it. So we might not have an eruption. We may have an eruption in the next few days. You can I think you'll probably hear about it depending on where you get your news and such. I'll try to update you and provide an update. If I hear an eruption has started, I will do my best to get on the computer as quickly as possible and update you about what's happening. So now that I'm back from our little vacation, look for a little bit more regular updates. But again, like I've done in the past, just look for those updates to occur as needed, right? I'm not going to push one out every day if there's not a whole lot to report or not a lot going on. But for now, we'll just kind of keep monitoring it and see what happens. These inflation deflation events are common. We saw that, and then they don't always end in an eruption. So, but the unrest is going to continue for some time. And again, it's just a fascinating little learning opportunity. And what I wanted to end with here, if you take a minute and indulge me for a second, is just a brief little recap as we end the year. It's typical for folks to look back and recap what's happened over the last year, and I just want to do that here with this YouTube channel that I've put together and cobbled together over the last few years. And you're all a part of that. You're part of this community. And so this last year, here's the number of videos I did, sort of in different categories. And since we all love a good pie chart, there's a nice pie chart that shows the distribution there. So field videos where I go outside and explain the geology of a specific location, those are my bread and butter. Those will continue to be the main thing that I put out. Of course, with all the events happening in Iceland at the end of this year, there was 26 or so video updates, not counting this one. I did 8 live streams, and I'll probably do more of those going into the next year. We launched the new Random Road Cut series, which aren't the most popular videos in terms of views, but wow, they really do have kind of a cult following. There's people that just really love those more than anything else. So I'll continue to do those. I mentioned the field videos, just presentations that I get video copies of that I can share with you, like the Bonneville Flood one, or I have one on Iceland, just an overall geology. I'll put those out. And then my wife, when she has time, which isn't very often because she works in the school system here locally, she had fun cobbling together some of my little climbing videos with the little geology and putting together those little YouTube short videos. And I was able to put together videos in 8 states and 2 countries this last year. So we were able to get out to a lot of different places together. So that's fantastic. Um, and then seeing the growth of our community here on YouTube has been really awesome. I started this year, January 1st, 2023. I had a little over 12,000 subscribers, which was awesome. And I was just super happy about that. And you can see the nice kind of steady linear growth over the year. Kind of picks up as I went to, Iceland and Hawaii and the Grand Canyon. Things were looking good. We got to about 30,000 people in beginning in November. And then you can see the big jump here. That's the big, crazy news cycle. Iceland event taking place in mid-November with the evacuation of Grindavík. Then it kind of tapers out a little bit, and then another little bump here when we had the eruption December 18th. And so now we're sitting at just shy of 80,000 subscribers. And I want to thank you all for that, because when I address you as team or crew or whatever silly little phrase I use, I really do mean that this is a community of people learning together. I'm happy to be, I guess, the coach of the team, whatever my role is, but just kind of helping you learn. But also it helps me. I learned so much as I'm going to new places, learning about the geology of some place I've never been to. The emails I get from people, I learn a lot. And so it really is a learning environment. I hope you appreciate that. And I hope you realize too that my stuff's not slick. It's not well produced. I am not a YouTuber at all. I am a geologist first, an educator second, and I have a YouTube channel. So I have a platform where I share those things that I love. But we're learning and growing together, and I hope you had a great 2023. I hope 2024 is even better. I'm looking forward to big things, field trips with YouTube viewers. I did 2 last year. I've got more planned for this year. More places I hope to get to in the coming year. Some of that's scheduled, some of it's sort of not yet, but I'll figure it out. And I'm hoping that it can grow, not to make the numbers grow, but by reaching more people, that makes me feel good. It makes me feel good that more people are fascinated by Earth processes, that they appreciate the Earth and all its wonders, that they learn a little bit, and more importantly, that they see the Earth differently. I often think about geology education as like a new set of glasses. So when you go on a road trip or you're outside, you see things a little bit differently. Rather than this static environment, you start to see and interpret processes, and you can see the history of the place and how things formed. And the words don't matter, right? Palagonite and agglutinate and fancy names we use, those are fun, but more importantly, my goal with all my students, whether they're here on YouTube or in my college classrooms, is that people understand the processes, and it makes them better educated so they can be more informed citizens, and that it brings some value and edification to their lives. And if that's where we end up, then mission accomplished, and we've all done a great job there. So with that, thanks so much for indulging me with this last little update of 2023. I'll see you soon in 2024. Look for some more field videos. I've still got a backlog of those that I'm going to push out. Thank you for all your support, comments, emails, financial support. Anything you've done to help me out has been really appreciated. And it's just a fun side gig, right? My main focus is what I do here at the college, but continuing to do this on the side is just a super fun project for me, because it's really stuff I'd be doing anyway. Being outside, looking at rocks, it's not much harder to grab the little camera and show it to the rest of the world while I'm out there doing it. So with that, have a great New Year's. Appreciate your time, energy, and viewership. And onward and upward, team. Take care.